Hi. In this video, we are going to containerize the machine learning model that we developed in the previous video and then deploy it on Kubernetes platform. So what we'll be doing is, if you have seen my previous videos, we built a TensorFlow model for sentiment analysis. And then we built a Flask application that we deployed in a local environment and enabled serving of that particular machine learning model. Now we are going to take the same Flask application and then containerize it and then deploying it on Kubernetes platform. And for Kubernetes, we are going to use Google Kubernetes Engine. The steps are very similar irrespective of you go into Amazon Kubernetes or you build your own Kubernetes engine or use Azure Kubernetes engine. The steps are pretty much similar. There will be one or two steps where you use the cloud specific command, but other than that, the process, the steps, the code, everything is very much same. So if you're not seen my previous set of video, I have in the video description I have highlighted all the different code from building the model to creating a Flask application. You can see the video description, or if you want to go specifically into the Flask application video, building a Flask application of the machine learning model, you can click the link on the top and then watch the Flask application video. But just to give a quick overview of the model that we developed, basically what we did is we took an Amazon mobile electronics review data set, and then we created a pipeline for training the model. We did tokenization. Basically, we are trying to do an sentiment analysis, and for that, what we did is we did tokenization of the incoming reviews that are there. We are splitting by tokens. We are doing a token encoding to convert the tokens into a more numerical value that the model can understand. So we had an embedding layer where we did the token encoding. Then we have batch padding. So what we are doing to make it uniform for model to train it, we are padding it by spaces or by zeros in this case, right? So we are doing padding by batches rather than padding the entire data set. And then finally we trained an LSTM model which gave an output, and then we have the model, we saved the model. That was about the training part of it. Coming to the deployment part of it, what we did is we created a REST endpoint using Flask, and then we took the token encoding data, which is the basically words that are there into numerical convert into numerical value. We have taken the token encoding file, we have saved it, we loaded the model that is coming out of the bidirectional LSTM model, and then we did the other token encoding, padding, and everything, and then the Flask application was up and running. Right. So now let's go and see how we can deploy the Flask application. Right. So the very first thing I'm going to do is you can create a Google Cloud Platform account. If you are new to it, you will get a $300 credit, which you can very well use and play around with a lot of different models and even train the models or use other features of Google Cloud Platform. The cost incurred for this is very minimal. Out of the $300, you may hardly spend some $10, or I would say like even $2 or $3, depending on how much your time you're going to use it, what different options you're going to try it out, right? So the different things that we are going to use is, we are going to use first is cloud storage bucket. So let me go to the cloud storage. So you can type in the command to go to respective GCP services, and in that I have created a bucket called tf_flask_app, and I have uploaded all my code into this. I'll walk through the code. I'm not going to walk through all the Flask code, but I'm going to walk through the additional code that is required to containerize it. So this has the Flask application. This has the GUnicorn application. It has the other deployment.yaml file required for Kubernetes. It has the Docker file required to create a container. Right. So these are the different files. I will show you the changes that I made to deploy it in for deploying in a container environment. Right. So this is the bucket that I have created and uploaded my code. Now, other thing I'm going to use is basically container registry, which is again a Google provided services, which is similar to your Docker hub. So container registry is currently there's nothing because I have not uploaded anything. So container registry is very similar to Docker hub, where you create a container image that you want to use, and then you upload it into an Google container registry environment. You can also upload it to Docker hub, but since I'm in GCP, I would prefer to have it in the Google container registry. And the final service that we are going to use is Kubernetes Engine. So Kubernetes Engine is basically it allows you to create an Kubernetes cluster. It's a managed service rather than we installing Kubernetes and doing it by ourselves. We will just be using the Google Kubernetes Engine. Again, we don't have a cluster now. We will create it using command line as we go into the details of it. So let's get started. One more service I'm going to use is cloud logging to log the output of the Flask application. So cloud logging is a Google service again. Rather than logging it in a local drive, mounted drive or something like that, I want it to be centralized in the Google Cloud platform. So I'm going to use Google Cloud logging. I will show I will talk about that when I get there. So let's get started. So this is on the top side on the menu. You will find an activate cloud shell. So this is the cloud shell. It's give a command line shells on which by which you can work on to Google Cloud services. I'm going to click that. I'm going to, you will see the cloud shell opening in the bottom. You can click this icon so that you get a full screen window of it. Right, and just remember my project name. Like you can have multiple projects within a GCP environment. My project name is Srivatsan project. Right, it's Srivatsan project. That's the name of the project. I need it over there. So let me clear the screen over here. So this is my Google Cloud shell, and using this shell I can run Google Cloud utilities and other utilities to perform Google Cloud operation. Right, so let me first do an ls, and that is nothing. So the very first thing I want to do is I want to copy my Google storage code that I have loaded into Google Cloud Storage into my local cloud shell environment. That's the first thing I'm going to do. So there is a utility called gsutil. Now gsutil is a Python utility that will allow you to work with the GCS cloud storage bucket. Google Cloud Storage bucket, right? When I do a GS utility ls, you can see basically that is an TS Flask app, TF Flask app. That is the bucket that I have, that we saw over there, right? Now let me do one thing. Let me just do an GS util ls, and then let me just list the content within the Flask app. So when I do it, basically you can see all the different files available there. So you have a Flask file, you have a gunicorn file, you will have a deployment YAML file. And these are the two models. One is the encoding file, and second is the sentiment analysis model, TensorFlow model, that we have saved as a HD5 file. Right, so these are different environment. So the very first thing I'm going to do is I'm going to copy it into my local drive. Right, so for that, what I'm going to do is I'm going to use gsutil again. Now gsutil is very similar to your HDFS command line utility. Here it's going to access Google Cloud Storage. So I'm going to use gsutil cp. I'm going to do a recursive copy, and I'm telling that copy this particular folder, which is the GS bucket, into my local drive. And what it is going to do is it is going to take all and copy into my local drive. The models are getting copied, the files are getting copied. So it is going to take like a few seconds. Let's give few seconds. Yeah, now let me do an ls. You can see basically, let me clear it out and do an ls. Now you can see basically there is a TF Flask app folder that is downloaded from my Google Cloud Storage to the local environment. Right, so let's quickly go into that particular directory and do an ls-elrt, and you will see all the files are there. Now Google Cloud Shell also provides an editor which will allow you to view and update the file. So I'm going to use that editor. On the top, if you click this particular, there's a pen kind of icon. That's a editor icon. When you click on this open editor icon, it will open all the, you can also use vi or cat command, anything with the shell, but this gives you a pretty good IDE kind of environment. So you see the editor over here, you see the folder over here, and you see all the files. Right, this the Flask final app is very similar to what we built. The only thing I have added over here in the Flask application that we built last time is I am importing Google Cloud logging, so that I want to, earlier I created a logging environment and logged it in the local drive because I was running it in local. Now I want to use Google Cloud logging for logging. So I am importing the Google Cloud logging and adding this to command, where I am telling it's a Google Cloud logging client, and I want to redirect all the logs to my cloud logging environment. Right, now said that, basically if you see the other command are pretty similar, logging.info, and whatever we do with the Python logging, the other commands are similar. And I have commented out this logging basic config where I am telling log it into flask.log because it was required when I was logging it in my local environment. Now I am going to just use Google Cloud logging for it, right? And if you see, the other commands are pretty much same, right? The other commands, I am doing a L check to check how is my flask app, whether it's running or not. And I have a predict function which is called by the routing condition SC classifier that will return me an whether it's a positive review or a negative review, right? I also have a GUnicorn. So basically Flask is a single threaded app server. So in order for me to make it multi-threaded or run multiple workers on a single node, I'm using GUnicorn over here, and that will allow me to scale the incoming request, right? Now, for creating a container specifically, right, I need to write a Docker file. So Docker file provides you the instructions that are required to create the container. Basically, when you are running a container command, it's going to read the Docker file and it's going to follow the steps that are there in the Docker file. And that's what basically Docker file does. And it's a text document that contains all the commands a user could call on the command line to assemble an image. Now, when we talk about Docker, the content within the Docker image are self-contained. When you take machine learning model, you may use multiple libraries. You may use libraries like Pandas, NumPy, or you may use TensorFlow, Scikit-learn. You may use NLTK libraries. There will be multiple libraries that you will be using. And what you want to do is you want to package everything together so that you can run as a completely standalone container. That's what you're doing over here. So the very first thing I'm doing over here is I am picking a predefined image, that is a Python 3.7 slim image. And in turn, if you go to the repository and see Python 3.7 slim image, it comes with its own Debian Linux OS and other thing. So then I'm setting an environment variable called app_home as /app. So this /app is within the container. I'm just setting an environment variable, and I'm setting my work directory. The directory I want to work on, basically I'm setting it to /app. So in the container, the working directory will be /app now. And what I'm doing next is I'm copying my local drive content, whatever is there in the local drive. I'm taking it, I am copying it into the /app folder. So all my model, all my Flask Python file, GUnicorn Python file, everything will move into the container. And then I'm telling what dependency I have for this project. So if you remember, for this project, we require TensorFlow 2.1.0. We require TensorFlow datasets. We require Flask. We require GUnicorn. There's a L check component which does L checking of basically the Flask app, and the Google Cloud logging SDK that I kind of showed you some time back. I'm importing so that the logs can go into cloud logging, and I'm calling the run command. Basically, run command is it allows you to install your application and packages required for the Docker container to function, right? And then finally what I am doing is I am basically doing a command operation. So command, what it does is when a container starts, when the container is building, it will run only up till run command. But when you call the container and deploy the container in Kubernetes or any other container orchestration framework, the command will get executed. So in that command execute, I'm telling call the GUnicorn, and then call the SAGUnicorn, which is my, if you see here, SAGUnicorn is my Python file for GUnicorn. I'm telling call the SAGUnicorn app, and then I'm telling give one worker and 8 threads. Now you can have multiple workers also. So the difference is like workers does not share memory, whereas thread shares memory. So when I say one worker, the model will be loaded once and there will be 8 threads. Now you can have 3 workers and 8 threads each as well. So in that case, the model is basically loaded multiple times within each worker. And GUnicorn takes care of restarting if there's a failure or something like that within that worker. So this is the Docker file that we have. I'm going to go to the editor. There's one more file that we have for Docker. So this is called Docker ignore. So if you see, like I'll just show you what it is. In the Docker ignore, we give files that are not required to go into the container. So I'm telling, like, if you are downloading a Flask app from GitHub, you will have a README file. I'm telling I don't want a README file, and you can do that. You can also download from GitHub rather than the Google Cloud storage. I just kept Google Cloud storage because I've uploaded it and it's easy for me. I don't want a Docker file. Docker file is only required to build the container image. You don't need it inside. And if there is a compiled file, compiled Python file, or if there is an optimized Python file, or if there is a PyCatch file, all these things will not go into the Docker image. So this is the Docker ignore. So for building the container, we need the Docker file and the Docker ignore file. These are the only two things that are required. Right now, in this video, what I'm going to do, I'm going to more focus on building the container and then uploading the container into the Google Cloud Registry so that we can deploy it in Kubernetes. In the next video, I'll be going into the detail of Kubernetes. So for deploying this application as a container, we will be using a utility called gcloud. Now, gcloud is a command line interface that is a primary command line utility for any Google Cloud services. So if you want to spin up a Google Kubernetes Engine, or if you want to deploy any application into containers or any other services of Google, you will be using the Google Cloud command line utility. So here I'll be using the Google Cloud command line utility. And the very first thing I'm going to do is I'm going to see what is the project that is set. So if you have multiple projects, you may have a different project that is set. I want to make sure I am deploying this in the correct project. So basically what I'm doing is I can call a gcloud config get value and project, and it is going to show me what is the current active project. So in this case, Srivatsan project is the only project I have, and that is the active project. Now you can also use gcloud config set project, right? Rather get value, you can say set project and set a specific project if you want to deploy in any other project, right? I'm going to clear the screen off so that like we see it from the top. So basically that's what I'm going to do. The project is properly set over here. Now what I'm going to do is, if you see over here ls-art, I have all the files over here. Now I need to call the basically Docker build, right? When you call the Docker build, it will go into the Docker file and then look for the instructions that are mentioned and build the container for you. But in Google Cloud, instead of Docker build, I am going to use something called gcloud builds. Right, you can, in typical, if you are a local cluster, you will have Docker build, but here since I'm using a managed service of Google Kubernetes Engine, I'm going to use mostly gcloud command over here. I'm going to build a container and put it into a Google container registry. I'll show you after I have built the container. So what I'm going to do is I'm going to say like gcloud builds. I'm going to say submit the build, and then I'm going to give like where this build has to go. So -hyphen tag is the command, and gcr.io is the repository name. Like you have a Docker hub, there will be a repository name. You have gcr.io, which is nothing but Google Container Registry.io, and I'm telling my project name, which is Srivatsan-project. So I want to create that particular container image within my project, and I'm just giving a name for the project. So I'm telling like, okay, it's a sentiment analysis flask app, and it's created for a Google Kubernetes. And I'm just giving some name over here, and then I'm telling on where my Docker file location and everything is there. So everything is in the local directory. I'm just giving a doc. Let me run this command. What it's going to do is it's going to go and check the Docker file. It's going to read the instructions, and it's going to build the Docker image for me. And it's going to, you also use the .docker ignore file to see which images need not be built in the container image. So if you see here, you can see all the instructions that we gave over here. Just okay, now the build has started. And then it's the first step is, you can see here for Python 3.7 slim, it is using the Python 3.11 image, and it got that image. Then it is setting the environment variable app home, right? And then it's setting the work directory to app home. So whatever instruction we have given him, it will follow that instruction and create a container image. It is now trying to install all the dependencies. So the one good thing about Flask is your app is self-sufficient. So tomorrow, if you want to move from your the model training environment to model deployment environment, you can just hand over this container to your deployment team and they will deploy it. In fact, like Docker and Kubernetes, I have a separate video on why we require Docker and Kubernetes for data science. You can click the link on the top and check it out, where I have highlighted the benefit of Docker based deployment. It's going to take some time. It's going to install all the dependencies and build a container image that we can deploy on a Google Kubernetes Engine platform. So basically, once the container is ready, right? Let's also go if this is the Google Cloud Console again. I'm just going to close this bottom window. Let me go to container registry and basically see what is happening currently. Like still the Docker is not built, container is not built, it's just still installing. So once this is built and installed, it will push the container into an container registry. We can see at that time, since I'm installing TensorFlow, TensorBoard and everything, it's going to take some time over here. Now how this container is going to get used, I will show it in the next video. So basically we are going to take the container that we have built, and then we are going to create an Kubernetes deployment object. Now the code is same, right? We are not going to touch the code for anything. The only thing we are telling is we are giving instructions. We are giving instructions on what we want to do, right? Like we have the Docker file over here. Kubernetes also have a set of files called deployment files and service files and everything. We are going to create those files. We are going to show what is there in the file, and we are going to basically embed this container image within the deployment file. That's what we are going to do. So while this is, I think it's almost done. It should take few more seconds. So now you can see basically the container is created, and finally now we can go back to our container registry and then refresh it again to see if the container image is there. So now if you see, like you can see basically the container image is there. It's there in the Google container registry.io, and this is the container image, and we have only one version of it. Now if you have multiple versions, so what happens over the time, you may get new model version, you may want to do A/B testing or something else. So basically you will keep updating the container registry, and you can see multiple version over here that allows you to roll back as well if there is any problem with the new version. And always the latest version as the tag called latest. You can call with the particular version as well, but if you don't give, by default the latest version will get called. So basically the container is created, and you can see like a command line. Let me just clear it over here. There are some command line utilities as well, where you can go and check your container status. So basically what you can do is you can do gcloud builds. Gcloud builds is used for creating the container, and you can do list. It will show you basically the list of containers that are available, and you can see like all the basically this is the latest one. This was created some time back. Other than that, these are previous containers which I have been playing around. So there are multiple containers, and you can also go ahead, do just type like gcloud builds, and you can basically see the different options available. If you want to get the log of this particular container image, you can just type log, and then you can give this image name, whatever image log you want. You can give the image name. If you want to just describe the particular build, you can use the describe command, and you can basically give again the build name, and it will describe what has happened during that container creation process. So now what we have done is we have built a container. That is the first step. Now this container, we want to basically deploy it in our Kubernetes platform. And here in the next video, I will show you how to take the container and deploy it in a Google Kubernetes Engine platform. So stay tuned for next video. And again, as I said, the process is same. The code is same. Instead, if you want to run it on a local Kubernetes engine or local Docker engine, you will just say like Docker build. If you are going into AWS, you may use AWS specific command. If you are managing your own environment on cloud, Kubernetes environment, you will use the same Docker command. So only this command changes. Once we go into Kubernetes, the command is exactly same. Only in case of Docker build, we are using Docker build, gcloud build command. But in case of Docker, you will use Docker build command. So that's it with this video. Let's see you in the next video. Thank you.